Hi, welcome to this video. In this video, I'm going to show you guys a few examples on solving logarithmic equations. Alright, so we're going to solve a few examples that involve logarithmic equations. Now, the first thing that I would like to point out is when we are solving log equations, we must always check it. We have to I call them sub and check. So let's say today we are able to solve for x and x is equal to two values. We must substitute both x values back into the equation because one of them might work or maybe both of them might work. When we talk about log functions, if you guys remember the shape of a log function looks like that, where I'm going to have a vertical asymptote, right? So if I have a vertical asymptote, I won't be having any x on the left hand side, right? So there is a sort of like a limitation of where my x can be. So that's the reason why we have to carry out sub and check. You will know what I mean by that from the examples that I'm going to show you. Okay, so let's do the first one. Here I have log x squared and the whole thing to the base of a is equal to log of 3x plus 4 to the base of a. So what I'm trying to solve, which is my x over here, I'm not sure if you see this, so let's kind of use color coding to help us out. I have log a, and log a of something, the left is equal to the right. In other words, I can automatically look at this part, right? So the ideal working will be this. So the fast way is to say, okay, I know for sure that I'm taking log of something is to the base of a is equal to log of another thing to the base of a. So I can say x squared is equal to 3x plus 4. Make sense? So this is the fast way, right? And that makes sense. So let's just solve this for now. So I'll move everything to the left hand side. So your previous knowledge on solving quadratics, that definitely helps. So x minus 4, x plus 1 is equal to 0. So my x is equal to 4 and negative 1. Okay, so let me show you what I meant by sub and check. So now what I'm going to do is I'm going to substitute this in there. Okay, and we will see if the equation makes sense. So let's do that. So I will have log of, this is 4 squared, which is 16, to the base of a. Is that equal to log of, to the base of a, 3 times 4 plus the 4. Okay, so on the left hand side I will have log 16 to the base of a. On the right hand side I will also have log 16 to the base of a. So that's good, no problem there. Now what if I try this? I'm going to erase all this. What if I try this with negative 1? So let me erase all of this. So if I try it with negative 1, I will have log of negative 1 squared to the base of a is equal to log of 3 times negative 1 plus the 4 to the base of a. So let's see if this is true. So I'll have log, this is going to be 1, negative 1 squared gives us 1, is equal to 3 times negative 1 gives me negative 3 plus the 4, I will also get a 1 there. So this is also good. So my x can be 4, my x can be negative 1. Alright, now, so here I kind of used my observation. We came up with this equation here, pretty much with my observation, right? So if I'm taking log of something to the base of a is equal to log of something else to the base of a, in order for them to be equal, these two things must be equal, right? So that's how I came up with this equation here. Okay, but what I'm going to show you guys here is the proper algebra steps. The the proper algebra steps would be this. I'm going to write in red, okay? So since I'm trying to get this x squared out, which means I need to do something to the left-hand side, so the log to the base of a goes away. In other words, my inverse. So what's the inverse of this? It's a to the power of that, right? A to the power of the whole thing. And I'll do the same thing to both sides. A to the power of the whole thing, a to the power of the whole thing. So since the exponential and logarithmic, they are inverse of each other, the left-hand side cancels out, the right-hand side also cancels out, and I would end up with the same equation that I have there. So that's sort of the proper, so to speak, the proper algebra steps to get us to this x squared is equal to 3x plus 4, right? Okay, keep in mind that my sub and check is important, okay? All right, now let's look at the next example. This example, we have natural log. We have ln. And on the left, if today we don't have this part, then it's easy, right? But now we can't just say 12 minus x is equal to x plus x minus 5. That doesn't make sense, right? This is wrong. So we can't do that. But what we can do is, can we try to, let me use the right color. So my left hand side, I'm not going to touch it, but my right hand side, let's try to combine these two log terms into one. So how can I do that? If I have a plus between them, then I can multiply them, right? Does that make sense? So this is just simply applying the laws of logarithms, okay? So if I'm taking the natural log of this is equal to the natural log of something else, that says these two items would be the same. They're equal to each other. So that's the equation I'm going to come up. So this is x multiply x minus 5. So let's distribute. I'll get x squared minus 5x. And let's move everything to one side. I'll have 0 is equal to x squared. Minus 5x plus x becomes minus 4x. And then minus 12. And I can factor this. I'm going to have x 6 and 2. And negative 6, positive 2. So my x is equal to 6. And my x is equal to negative 2. Now, don't forget to sub and check. Sub and check. We need to do that. And this example will show you why we have to do it. So let's start with x equals to 6. Okay, I'm going to put that in my original equation. Put in there. So if I have, let me use red. Okay, so if my x is equal to 6, that line becomes ln of 12 minus 6, I'll have 6, equal to ln of 6 plus ln of 1. So I would have ln 6 is equal to, so if you add them, you can multiply 6 times 1 gives us 6. But this is good. Alright, so x equals to 6, no problem. Now let's try x equals to negative 2. Okay, I'm going to use green. Let's use green. So ln of 12 minus 2, so that becomes negative. That becomes 14. Or maybe I'll show you the steps. 12 minus 2 becomes 12 plus 2, and this is equal to on the right hand side I will have ln of negative 2 plus ln of negative 2. Oops, sorry about that. Plus ln of negative 7. Right, ln of negative 7. So what's this? What is this? If you think about it, how does the natural log graph look like? Something like that, right? Y equals to ln x. Again, I have a vertical asymptote there. So can I have any x value that's negative? I can't, because this becomes undefined. Right? Becomes undefined. So which means -2 is not, okay, -2 is not a solution. So I hope you guys see why we need to carry out sub and check. It is very important, yeah? So even though we might have two x values, but only x equals to 6, that's the only solution. So if you had put down -2, make sure you say just cross it out, so that the points won't be taken off. Okay? Alright, sometimes I have two more examples, and they're somewhat easier because sometimes we can solve logarithmic equations by converting them to exponential form. So if I convert this to exponential form, I will have 5 to the power of 3 is equal to x minus 2. 5 to the power of 3 is 125. Let me move the 2 over. Plus 2 is equal to x. So my x is 127. So if you want to check log 5, 127 minus 2, that's going to be log 125 to the base of 5. That's going to be 3. So it's all good. So x is equal to 127. So this is interchanging between exponential and your log form. Okay, if you exchange them, sometimes it really helps. All right, last one. Take a look at this. On the left, I have log x to the base of 2 plus log x minus 2 to the base of 2. So since they're both to the same base and I have a plus, what I can do with them is combine them using the properties. Right, so I can combine the two logs into one log, and now I'm going to convert them to exponential form. Right, so I have 2 to the power of 3 is equal to x times x minus 2. So 8 is equal to x squared minus 2x. Move the 8 over, then I can factor it. Okay, so my x is equal to 4 and my x is equal to -2. You guys see that the skills that we learned in the previous chapters, quadratics, for example, domain and range, for example, we can't just forget them, right? So we need to make sure we remember the skills, hopefully. If not, you can take out your notes. Now, the last step we have to do here is to stop and check, because maybe maybe that's not a solution, or maybe the 4 is not a solution. We'll see. So let's put that in. My x equals to 4. So let's put in the original equation here. So I have log x, my x is 4. In this case, the first one I'm testing with is 4. Plus log 4 minus 2. And we'll see if that's equals to 3. So log 4 to the base of 2, that gives us 2. Plus this becomes 2 as well. So log 2 to the base of 2, that gives us 1. So that is 3. So that's good. So my x equals to 4, that's a good one. Let's test with x equals to -2. So I'm going to erase this so I have some space. So feel free to rewind if you have to. So if I have my x is equal to -2 over here, my x is -2, then let me put it in. I will have log -2 to the base of 2 plus log -2 minus 2 to the base of 2. Now I'm not even gonna try to solve this because that's automatically undefined. My domain cannot be negative, right? This is also negative. So obviously I need to cross that out. So make sure you cross this out, okay? So by showing this, you need to find both values. Let me see. Okay, so what you have to do is, so once you have solved for x, you have two values, and then we sub and check. So when you're carrying out sub and check, you can do that on that could be part of your working, but that's not necessary. But what is essential, what's necessary is you have to cross that out. You don't really have to show the sub and check process, because maybe it's in paper 2 where you can use your calculator, but make sure you cross it out. If it's in paper 1, then I would recommend you to carry out sub and check and leave that as part of your workings. Alright, this video is a bit longer because I am making one video just to show you guys how to solve logarithmic equations. I hope you guys have some questions for me and we can discuss that in class. I will see you in the next video. Bye bye.